Hey guys, welcome back to the next video. In this video, we're going to see node affinity, but this time it's with preferred rather than required. So the previous video, we have seen required over here. It was very simple. The required world was so simple that, when you put required during scheduling, which means that it is mandatory to have this parameter as part of your node label. So that's very much specific over here when it is doing this work of allocating workload on your particular node. But here, when you talk about node affinity, which is using the preferred word, so preferred during scheduling, so this is the word I'm talking about, it becomes much more complex. It goes to the next level. Now, how complex it becomes is like, one can have multiple preferences. Okay. As in, like, one can have multiple, requirements can be very simple. It will be straightforward. I need this to be required, and this is pretty much straightforward. But then the preferences, we talk about it, it has multiple preferences. Now, this is where the complication comes in. So here I have three preferences over here, where one is that you put it as in a wait status, and then wait 2, wait 3. So I'll explain you little by little, but then what it is meaning is that in terms of wait 1, it is telling me that the higher the weight, okay, let's start like this. The higher the weight, the more priority it is. Okay, so when if I am this kube control which is looking at this file, so I will not be looking at the weight number 1. So what I will be looking at is weight number 3. Okay, because higher the weight is, the more the priority it is, okay, for it to check. It's going to do the same thing. It's going to still look for the node affinity, which means that it will look at the node label, and then it will basically schedule this particular pod on that particular node. Okay, so now if you look at it, we have to go from weight 3, because this is the first preference for it, even though the weight 1 is there as in like 1, which means that that's the number of weight, or the weight which it carries. But according to the preference of your preferred during scheduling, it will look at weight number 3 as a first preference over here, because it has the highest number of weight. And in this preference, you can see that it is trying to match an expression GPU equal to true. Obviously, this is some parameter we have assigned it as part of our existing label. So we have done it on the previous video. But we don't have these labels over here, which says, which is for weight 2, which talks about disk type is SSD and region is US West 1. Okay, so now we have option of creating these two labels as well as part of our worker. Okay, so we will first do the creation of labels, and then we will basically allocate these labels as part of our nodes, and then we will go ahead and do this change. Okay, now what I'm going to do is like to complicate this, right? So what I'm going to do is like I'm going to first bring up the kube control get nodes. So -o wide and -, show labels. So we will see the existing labels over here. And this is the manager. You can ignore this. You can see the worker 1 and worker 2 over here. So worker 1 and worker 2 has this information of the labels over here, where only the GPU true is enabled over here and GPU false is enabled in terms of worker 1. So let's just label this little more in detail. So kube control label, and then nodes, what you want to label and which node you want to label. Select that node. What label you want to give. I want to give, firstly, we'll go for the region selection. So as you can see over here, in all my examples, the worker 1 will be on the left, and then worker 2 will be on the right. So we'll go by this only. We'll go by US East as the worker 2 and US West as worker 1. Just west side is on the left side and east side is on the right side. So we will go with the separate, using the left side and the right side. Okay. So let's just name region equal to US West for the worker 1, because it's on the left side. So we'll go with this label, and then US East 1 for worker 2 because it's on the right side. Okay, so we have labeled the region as well. Now, in terms of SSD or the disk type label, we will give SSD for both of the worker 1 and worker 2. Okay, this is just to confuse things around here. So both have SSD disk. Okay, so we just do quick control and just go back to the previous command. Just remove wide. Just gives too many information. Now here, if you see that the worker 2 is GPU false and here it is GPU 2 true, sorry. And then you have disk type as SSD for both. And the region over here for this worker 2 is east and the worker 1 is configured on west. So if it needs to be configuring this particular, particular value based on preference, now first it will try to match this and then try to match this, okay, because it's a preference. It needs to it tries to match everything. But where it fails is like to match this, because what we have enabled GPU true is where it is in the east zone. Okay, but where it is actually looking for is in the west zone. So let's see what happens, right? There's no harm in getting this failure because that's how you learn. So let's keep this in mind. Show labels. Just put this as part of this notes over here. The shortcut of notes is NO. Okay, so now you have this information over here, and now let's just expand this a little bit. There you go. So now let's VI this particular file. So VI, what was the last one? 8, right? Let's make it 9. VI wm9.yaml. Now in this file, I'm going to copy paste the one which is on your document over here. Insert it. Okay. So now let's go from the beginning. So it's a pod creation and it is creating my pod on web application. App name label is web app. Append is backend, and environment is production. So this is some label which we need for your pod affinity. Okay, so that's the reason why we are defining this. We will talk about this later. And in terms of specifications, we are giving my container name Nginx as the image. And then in terms of affinity, we are using node affinity over here. And in the node affinity, we are giving preferred during scheduling, ignored during execution. Now, in terms of weight 1, we are giving preference over here as in to match the region as West 1, and then disk type as SSD and GPU as true. So there is also something called score. Okay, score is nothing but now you just have three weights configured here, right? So it depends on how much it can actually match. So if it can match all these 3 criteria, then 3 plus 2 plus 1. So weight 3 plus 2 plus 1. So it becomes 6, right? So it becomes like 6. That's the score of this. Okay, you cannot actually see the score, but then you can only see it by the pod, like how much it has actually used the selector to match it. So that's the only way to look at it. But then the score is something which you can make it on your mind yourself, seeing that, okay, it matched all my criteria, then it has like a full score. But if it doesn't match my criteria, all the criteria, then you need to understand that, okay, how much score it has got. So this is one way of calculating or understanding the preference which is matched. Okay, now save and quit this file. So let's execute this YAML. Control apply fnf w9.yaml. Okay, there seems to be an exception. So let me just check this and get back to you.